Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the multiple choice questions based on atomic structure. Which of the following has a positive charge? Atom has three fundamental particles. One is electron, another one is neutron and proton. Electron carries negative charge, neutron has no charge, and hence proton carries the positive charge. Option A is the right answer. Rutherford carried out experiments in which a beam of alpha particles was directed at a thin piece of metal foil. From these experiments, he concluded that Rutherford's thin foil experiments reveals the fact that the positively charged parts of the atom are extremely small and extremely heavy particles. So option C is the right answer. Consider the species zinc 72, arsenic 75 and germanium 74. These species have. So coming to the atomic number of zinc, that is 30, arsenic is 33, germanium is 32. So here we know the atomic number and mass number of three species. Thus we can calculate the number of neutrons by using the formula A minus Z. So when we calculate the number of neutrons of zinc, arsenic and germanium, they contains 42 number of neutrons. So in these three species, the number of protons will be same. So here in this case, option B, that is these three species contains the same number of neutrons. The neutral atoms of all of the isotopes of the same element have. So isotopes means they have the same atomic number but different mass number. So for example, let us consider carbon 12 and carbon 14. So here atomic number is same. Atomic number is same means they contains same number of protons and also same number of electrons. So in this case, option C, that means they have same number of electrons is the right option. What is the atomic weight of hypothetical element consisting of two isotopes? One with mass 64.2 AMU, its contribution is 26%, and another with mass 65.3 AMU. That means here we are having two isotopes. One is having the mass 64.23 and its contribution is 26%. That means its contribution towards the mass is 16.69 and that of 65.3 AMU contribution is 74%. That means it becomes 48.33 and on the whole the mass is atomic weight is 65.02. So here in this case, option D, that is 65 AMU is the right option. So here the atomic weight of the two species is 64.23 and 65.32. 64.23 contribution is 26. That means 64.23 into 26% gives 16.69. And the remaining isotope is 65.32. So its contribution will be 74% and hence it becomes 48.33. On the whole, its atomic weight becomes around 65. So option D is the right answer. Naturally occurring rubidium consists of just two isotopes. One of the isotopes consists of atoms having the mass of 84.912 AMU. AMU stands for atomic mass unit. the other of 86.901 AMU. What is the percentage of natural abundance of the heavier isotope? So actually the atomic weight of the rubidium is 85.46. Here two isotopes are available. One is having the mass 84.912 and the other is having 86.901. When we calculate the difference, it becomes 0.55, and for the another isotope it is 1.44. That means the lighter isotope will have more contribution. From these two differences, it is very clear that here the lighter isotope contributes 3 times than the heavier isotope, and its contribution will be 1. That means the percentage of contribution will be around 25%. Here in this case, let us check 28%. So if the contribution of the heavier isotope is 28%, then it accounts for the natural abundance, that is 85.46. So in this case, option B, that is 28%, is the right answer. What is the frequency of light having a wavelength of 4.50 into 10 power minus 6 centimeters? So here we are supposed to calculate the frequency of the light radiation. So frequency, how the frequency is related to wavelength? Nu is equal to C by lambda. So here the wavelength is given in terms of centimeters. So we have to consider the velocity of light also in terms of centimeters, that is equal to 3 into 10 power 10 divided by 4.5 into 10 power minus 6. Then that is equal to 0.666 into 10 power 16, and that is also equal to 6.67 into 10 power 15 second inverse. So option D is the right answer. The emission spectrum of gold shows a line of wavelength 2.676 into 10 power minus 7 meters. How much energy is emitted as the excited electron falls to the lower energy level? So here we are supposed to calculate the energy. So energy E is equal to h nu. That is equal to, h nu means hc by lambda. Here the wavelength is given and we have to consider the value of Planck's constant in terms of joules, that is equal to 6.625 into 10 power minus 34 joules. And here we have to consider the velocity of light in terms of meters, 3 into 10 power 8 divided by what is the wavelength of the radiation, that is 2.676 into 10 power minus 7, and on calculating you are going to get the answer 7.43 into 10 power minus 19 joules. So option A is the right answer. Which of the responses contains all the statements that are consistent with the Bohr theory of the atom and no others? So which of the following statements agrees Bohr's theory? So according to Bohr's theory, let us see what are the given statements. An electron can remain in a particular orbit as long as it continuously absorbs the radiation of a definite frequency. So whenever an electron absorbs the radiation, it jumps from lower orbit to higher orbit. It is the wrong option. The lowest energy orbits are those closest to the nucleus. It is the right answer. An electron can jump from the K shell, that means lower shell, to the higher shell by emitting radiation. No, only by absorbing radiation, electron can jump from lower orbit to the higher orbit. So it is also wrong. So only 2 is right. So that means option B, that is the right answer. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.